Today we'll be deriving time dilation with the Lorentz transformation. The Lorentz transformation for time dilation. To do so, we would need to consider two perspectives. The first one is when we have two mirrors and a single photon and it just bounces vertically up and down. Now we'll call this vertical distance h. Then we say that the amount of time, let's call it t0, it takes for the photon to make each round trip is going to be the total distance, 2h, divided by the speed, c. Now also, if we want to solve for h, we can say that h is equal to c times t0 divided by 2. Now the second case is when we say this clock is moving. So we have it's originally here, then here, and finally here. So we have that the photon takes a diagonal path instead, but we say that this distance is still going to be the same h. Now we say the clock is moving with some velocity v towards the right, and we call this diagonal distance L. Then when we say we want to figure out the time, we say t is equal to the total distance traveled. In this case, it's 2L divided by the speed c. Now, when we want to find the relationship between L and h, as well as v, we find that through the Pythagorean theorem, L squared is just equal to h squared plus t. So this is going to be v times t, so we want half of that. So we have vt divided by 2 and then squared. Now we want to cancel out our h's and our l's. So to do so, we can once again solve for L here to get that L is equal to CT divided by 2. When we plug that into our equation, we find that L squared is equal to CT over 2 squared is equal to H squared, which is CT0 over 2 squared, plus VT over 2 squared. Now, we want to solve for T in terms of T0, so we can move the t's to both sides to get c over 2 squared t squared minus v over 2 squared t squared is equal to c over 2 squared t0 squared. Now what we get then is if we take c squared over 2 squared out, we have 1 minus v squared over c squared is equal to c squared over 2 squared times t0 squared. Then we can cancel out the c over 2 squared on both sides, and when we take the square root, we find that t is equal times the square root of 1 minus v squared over c squared is equal to t0 squared, t0 without the square, and usually we can write this in terms of t as a function of t0 divided by 1 minus v squared over c squared. And thus we find this is a relationship between two different reference frames.